Hello everyone, this is Suharshini and Pratap is there with me in this presentation. Here we are implementing a toy model. For creating this model, we used agent-based simulation, which is the best suitable for addressing the spread of COVID infectious diseases like COVID-19. Because in this case, we can study the individual behavior of an agent and their interventions. Interventions such as mask mandate, social distance, vaccination. It simulates the state of an agent over the number of discrete steps and then calculate the probability of that agent on a time step. Based on the time step, it will change from one state to another state, like healthy to infected or infected to dead. Here, our approach is to implement vaccination and social distance as interventions and implementing batch run 2 in this model. Coming to the implementation part, vaccination, when infected comes in contact with a normal void, it gets infected. But the infected void comes in contact with the vaccinated void, it won't get infected for the first 2 times of contact. So the vaccination void is 3 times more resistant than the normal void. That was we have implemented in the vaccination. Next, coming to the social distance, when distance between void increases, the infection rate will be less. Here, we have a parameter called separate. As this value increases, the distance between void increases and the infection will be less. But we have as a slider value increases from 0 to 10 in the steps of 2. The distance increases from 0 to 5. Here we have a 3D graph, time versus separation versus vaccination. And coming to the batch runner, it is to collect all the parameters and run it in the command line. It is used to collect the step-by-step data of the model. This has been done by the data collector object in a model reporter. Then when it runs, a CSV file will be generated, which contains the data from every step of every run. The Pratap will continue the presentation on the sample runs.
Hi, this is Pratap. Before going to continue my discussion, so I would like to extend the discussion on batch running. So batch running is important thing here to collect our data. So here we have two kinds of data that we should collect. One is model generating data, and the another is data related to agent type. So here we can get the batch running by using this by running this line of code. So if we comment this line of code and when we run the code, then it will usually open the sample run. So when you give only this, it will start batch running. So how the batch running will happen is, here we have the list of parameters. So it will take the combinations of parameters from each point from social distance and vaccination. So here in the social distancing, it will take 0 and the combination of 0 with 0, 0, 0 with 0 0.2, 0 with 0 0.4. Likewise, it will take all the combinations. So we have around 25 of combinations, and so it will run 3 times for each combination, and the maximum steps it will run is 211. So this batch run will get only model data. That means what are the data that available after running each model. So we have another set of data. So it is agent based data. So in this agent based data, we will get the values of agent at each step. So this line of code that will help us to collect the data from each step. Now before and after completing 200 steps, it will generate the CSV file. Then this CSV file will store into a specific folder. So I will show where that will generate. So here in our folder we have a file. So these are the folders that we'll get. So this is the model data, and in this folder, in these folders, we'll have a agent based data. So for example, recently we have generated the agent based data. So for when we run the model for 25 times, then the data will generate 25 CSV files. So now we will take one CSV file as a sample, and we will explain how the data will be. So this is the agent level data. That means at each step how the agent behave at infection level, health level, recovery level, vaccination level. Now I am going to import this data into a Jupyter notebook, and we'll analyze the result. Before going to import, I will now import all the required packages. So these are the packages that are required to analyze the data. So after that, I'm going to read that specific file into a data frame, and this and I am printing the first 10 lines of the data frame. So you can see here the unnamed column. So unnamed column is actually it is a step count at each level. So I'm going to rename that unnamed to step in order to avoid the confusion. Before going to analyze data, and first I'm going to draw a bar graph for that. So these are sample bar graph that we got. Here we have infected, healthy, recovered, vaccinated, and dead. So by seeing this bar graph, we have the y-axis that represents the frequency. That means the duration of the time in which the model has run. And the zero value here that represents the dead. So currently in this model, we don't have a dead people. And then when coming to the vaccinated people, around 10 to 15 they are lasted for 50 steps. After that, they maintain the constant. So recovery. Then after the recovery, recovery was happening at a very high at the end of the spread, because the spread will increase by the end, and suddenly it will stop. So healthy agents maintain the steep downfall. So essentially, more number of people get affected. At the end, they maintain the constant value. So now coming to the analysis between time and record, we have a parameter here. When we look at this graph actual steps, the actual steps would start at 25, maintain a linear growth up to 75. You see here. So later on, it will follow the exponential growth rate from 75 to 150. That means the spread starts very rapidly after 75, because there is a potential number of agents, which is 10 agents, got COVID, and they are spreading it. When we look at the data analyzing between the vaccinated to vaccinated people versus the time, then there is only 6 people who got infection. But one important thing that we should observe here is, so in the above graph, after 75, we got exponential, exponential increment in the spread. But here after 75, it remains constant. There is no spread. So and when coming to the relationship between infected and time, here we know that we are starting with one infected person at the beginning. It increases slightly up to 25. Later got decreased because the recovery starts from there. After slight fall, the curve increase peaked suddenly and dropped down sharply after remains the constant up at 150. So it could be able to infect a maximum of 35 and minimum of 1, because we started with 1. So now when we come to healthy versus time, so we can say that only 60 people out of 80 got infected, and 20 people left without infection. Our attention is how these agents behave over a period of time and influence the model. So finally, this is the model we analyze at social distance of 2 units and vaccination agents with 20%. These two parameters has a huge potential to influence the spread. When we run the empty model with null parameters, so we end up remaining of 0 to 5 agents. But now we end up at 20 healthy people. So we can also extend this model by adding mobile agents and non-mobile agents to see more better results. Since it's a toy model, we have only limited scope to analyze the data. However, we are able to produce meaningful results. Thank you for being with us. Please comment more and we will answer all of your comments.